the others that were part of our program.
It's on.
There you go.
It's on?
Yep.
Ladybugs in space. I'm Kylie Dappin.
I'm Madison Gargiulo.
And I'm Megan Simpson. And we're from Mount Carbon Elementary in 5th grade with the SSEP Student Spaceflight Experiment Program.
Ladybugs are a breed of beetle and are beneficial insects for organic gardening or farming because they eat insects and pests that are destructive to the garden. Ladybugs primarily eat aphids, insects that suck the sap out of plants. An infestation of aphids can destroy whole gardens and decimate crops. A single ladybug can eat up to 5,000 aphids, which means they are invaluable to farmers trying to control an aphid population without the use of harsh chemicals. At the present time, experiments are being done in space to learn how best to grow food for possible colonization on Mars or other future suitable planets. Our experiment team wants to know if ladybugs can grow and be useful in future space gardens.
Ladybug life cycle. Ladybugs on Earth have 4 stages of life that last between 4 to 8 weeks: egg, larva, pupa, and adult. First, we have the egg stage. Once the female lays her eggs, the larvae typically emerge from their eggs in about 4 days. Second, we have the larvae stage. Once the egg hatch, the larvae, which look like tiny alligators, will start to look for something to eat, preferably tiny mites or aphids. Larvae eat the most during this stage than all the other stages. Next, we have the pupa stage. The larvae are starting to change into something that looks like a shrimp. The last stage that we have is the adult stage. The adult stage looks like what you see flying around outside. Adults can live up to 1 year. Our experiment will test to see if microgravity affects the development and growth of the ladybug life cycle. In our experiment, we'll be using a type 2 FME test tube, which is separated with 2 sections and it's clamped off in the middle. And the test tubes are really tiny, and they're only 6.7 inches long and 3/8 of an inch long in diameter. So there's not a lot of room for the eggs that we need to put in there, the food, and the water. So in one volume, we're gonna have 7 frozen dormant eggs, a rose leaf cut into 3 tiny pieces with a drop of honey on each leaf, 4 raisins cut in half, and half of a cotton ball saturated in distilled water. And then in the other volume, we're gonna have 3 drops of honey, 4 raisins cut in half, and the other half of the cotton ball saturated in distilled water. The first volume will be for the larva stage, and that'll feed the ladybugs for the stage that they eat the most on. And then about 4 weeks into the experiment, we'll ask the astronauts to unclamp the test tube so the ladybugs can get to the food and water on the other side. This will feed them for the rest of the experiment and their journey home. We'll be doing a ground truth test, which basically means we'll be doing the same thing down here on Earth, simultaneous to the one on the ISS. And what this will do is help us prove and compare whether the Earth ladybugs and the microgravity ladybugs had a greater survival rate and development rate.
When our experiment returns to Earth, we will analyze both the control group ladybugs and the microgravity group ladybugs to see if or how the microgravity group ladybugs developed or the development rate or the survival rate was different from the Earth ladybugs. We will look at each group and ask questions like, did any of the ladybugs hatch? If so, how many? Are any ladybugs in the larva stage or the pupa stage? Are there any adult ladybugs? Are there any ladybugs that are, how many wings, legs, and how many wings, legs, and spots does each ladybug have? After we have analyzed both the control group ladybugs and the microgravity group ladybugs, we will We will compare and see if or how the microgravity group ladybugs was different from the Earth ladybugs.
Thank you for attending our Ladybugs in Space presentation, and good luck to all you fellow competitors.